All right. So chapter 3 today. Chapter 3 is about pair functions and transformations. We'll get into inequalities a little bit later. But these several lessons are over transformations and what we need to do with those and how to graph those and all that stuff. So the first thing I want to talk about is the definition of a parent function. So the definition of a parent function, I'm sure if you looked it up online or looked it up in the dictionary or in a textbook, I'm sure to have like a paragraph that would be super confusing. So the way I describe a parent function is it's just the most basic form of that specific function. So really what I mean by that is it's if you take anything else out of that function, it all of a sudden is going to completely lose its identity. So what I mean by that is you guys all know that if you have or hopefully remember from Algebra 1, if you have x squared plus 2x plus 9, that's a parabola. If I took off the 9, it would look different, but it'd still be parabola. If I took off the 2x, it would look different, but still be parabola. But if I took anything else off of this, now that I just have x squared, if I took anything else off, all of a sudden it would not be a parabola anymore. So that's what a parent function is. Form of that function. The four that we're going to work with are x squared, x to the third, square root of x, and absolute value of x. Now, obviously, there are more. You could do exponentials this way. You can do, was it inverse equations? No, inverse. Anyways, there's several other that you can do with these parent functions, but once you kind of get the idea with these four, that'll help you understand all the other ones if you ever have to encounter those. You won't this year, but maybe in pre-calculus. I don't know how far you go into this stuff. The transformation part. So the transformation part is where you're manipulating those functions to kind of do what you want or to put those where you want. So we will be stretching those, we'll compress those, we will move those left, right, up, down, we will reflect those. Those are all different things, but we're always going to start, for our purposes, we're always going to start with a parent function. So when it says manipulations made to any function, to form a different one, that any function we're going to have is a parent function. Now, again, obviously, it can be any function. You can use whatever you want. We might get into that a little bit later, but for this stuff, we are doing the parent function. So before I get into this, I'm going to go back to this cheat sheet, and we're going to talk a little bit about this. Now, I put this line. You will get the top part of this on a test. I'll give that to you. The bottom part, I'm not going to give you for a test. I'm going to put something else there. But you will get this first part on your test. So we're opening with the graphs of your parent function. So if you graph x squared, that's what you get for the first one. X to the third, square root of x, absolute value of x. Those are the graphs of the parent functions. Eventually, we will take those graphs, and that's where we will start, and then we'll move them up, down, left, right. We'll reflect them. We'll do different things with those, but not today. So we're going to stop with those and move on to this table. Now, this table has a lot going on with it. I promise if you don't get overwhelmed and you just look at each little spot individually, this table is really helpful, and it's really not too bad. Again, I have had a couple people that they say that they just completely got lost and don't know anything that's happening. If that happens, that's fine. Please ask questions. It's okay. There is a lot of new stuff today. But if you can focus in and know that it's just each little step, you can refer back to this. That'll help. What these are, obviously, they start with the parent functions. And then I've seen problems where they don't do it like this. They break it down differently. But I went ahead and I put this breakdown for every parent function. Just so you need it, you can see, okay, well, if I'm dealing with a square root, I can look specifically at that square root problem. If I'm dealing with a cubic, x to the third, I can specifically look at that problem. But that said, if you notice, they're all the same. So this C is the same C in all of them. They're all minus h is the same minus h in one of them, and they're all inside, whether it's in parentheses, or inside the square root, or inside your absolute value. And the plus k, again, it's the same plus k in all of them. It's all outside the parentheses. It's all that last thing that you see. So what does all this mean? What's the x, what's the h, the k, what's the c, what does all that do? So those are the transformations. So what those look like is your first letter, if you have a number here, you might not, but if you have a number here, that means it's a vertical stretch or compression. Now, first off, we don't have any horizontal. I want you to say the word vertical when you write it out, but we don't have a horizontal, so don't get confused by that. That's a compression. If that number is bigger than 1, that makes it a stretch. If it is small, that makes it a compression. That's why I put those right above stretch and compression. I put these in absolute values, and I said this so positive, but really the big thing I want you to realize is if you have a negative with your C, that has no part of the vertical stretch. If you have a negative with your C, that goes something that goes with the reflection. So if you have a negative, you just ignore it for this part, because for this part, all you're looking at is the number, not the negative sign. So a couple examples real quick. If you want to jot it down, you can. You certainly don't have to. But if I have 3x squared, that means it's a vertical stretch by a factor of 3. If I have 1/2 x to the third, that means that is a compression, a vertical compression by a factor of 1/2. If you have a number in front, that's what that number means. Now, the next two are the easier ones. If you have it inside the parentheses, that means you're moving it left to right. So if you have a plus, that's to the left. If you have a minus, it's to the right. Now, the part of this, a lot of students miss this one. It's not because it's hard. It's not because they don't know how to do it. It's because they accidentally mess it up. Because it's opposite. If it says a minus, you actually go to the right. If it says a plus, you're actually going to the left. I can actually go into why that is. It's actually not really, I mean, if you squint your eyes, it's totally true, but really I can see where a math teacher would say, or a math professor would say, that's absolutely wrong, in which case I would physically fight them. So for our purposes, it just is way better to explain to high school kids that if it's a plus, it actually is the opposite. You move to the left, and if it's minus, you actually move to the right. If it's inside your parentheses, or inside your square roots, or your absolute value. So problems like that would look something like this. X plus 3 would go to the left 3. I was going to change that so it's not a square root. X minus 7 would be to the right 7. Now the next one, this one's my favorite. If it's on the last thing in your equation, if there are no, if it's not inside the parentheses at all, then if it goes up, it's plus. If it's minus, it goes down. And that one makes sense. Plus is usually up, minus is usually down. So that one we're usually okay with. So if you have something like x squared plus 10, that means you go up 10. If you have the square root of x minus 10 or minus 8, that means you go down 8. Now make sure you notice the difference in what I just put here. Inside the square root, outside the square root. Notice the difference. This one's under that little root. This one's not. Inside and outside your square root. Now the next ones are a little bit more confusing, and I don't know if it's because we don't have them a whole lot, but if you have a negative in front, so it's outside your parentheses, just like I put here, that is reflected across the x-axis. So that's going to be something like negative x squared, or negative square root of x. If you have a negative out front, that's reflected across your x-axis. If you have a negative inside your parentheses, that's reflected across the y-axis. So that's going to be problems like negative x squared, negative x inside your absolute value. If it's inside, that's your y-axis. Reflection across your y-axis. Here's the deal. You see a negative like this, and you don't know which one it is, go with the first one with the x-axis. You always get it right, but we have way more of those than this one. Surprising if this one doesn't even show up on the test. I haven't made the test yet, so maybe I'm wrong. What's probably even if it show up on the test? And if it doesn't, maybe it would be one question and you'll miss half a point. So not a huge deal. So don't stress about the reflections. I mean, obviously, if you really want to make sure you get an A+, then definitely make sure you know those. But if you miss that, there's not very many of them. Again, you can always default to that first one, and you'll probably get it right. In worst case scenario, you'll miss a half point. So to fill in this part in the bottom, you guys could probably do this on your own at this point. But it's the same thing we just talked about, x squared plus 5. Now, if you need to use your charts, somebody said this earlier when they said, well, I'm just really confused. And I said, well, use your chart. And they said, well, I don't know how to use that either. Well, if it's x squared plus 2, go up to your cheat sheet. X squared plus 2, that means we have plus 2 in the back. That means we have K. K means moving up or down. If it's plus, it's up. That's how I use this chart. 5. It's outside your absolute value, so it's down 3. Now again, same x minus 4. If you don't know, you could go up to your square root. That's this right here. Inside is minus 4, so that's that h. So find where h is. Minus 4 is to the right. 4. And that is how you can use this cheat sheet, and that's why this is pretty handy for when you guys take your test. And this one is to the left one. Then the negative ones I think are a little bit more difficult. If you need to use your cheat sheet, you can't really see it in here, but it's out front. So if it's out front, that goes with that C. So that's this one reflected across the x-axis. And if it's inside, that's reflected across the y-axis. Now, the only thing we didn't go over in front, if you have that number in front, that is a vertical. Again, we will not talk about horizontal transformations, at least not stretches and compressions like this one. If it's bigger than 1, then it's a vertical stretch. If it is smaller than 1, it is a vertical compression. The good news is, whether or compression, you take that number, you'll take your y value, you'll take your y value and you multiply by whatever that number is. So we'll talk more about that later when we get to the graphing. Once you know what that number is, whether it's a stretch or compression, doesn't matter. You can multiply by your y value. Y value, not y-axis, but that's okay. Going back to the notes, the only thing we didn't really talk about is the parent function versus just having a generic function f of x. Now, the good news is it's the same thing. So what I did here, and I need to reorganize this a little bit. Once I taught this, I figured out it wasn't the best setup. Notice how number 1 and number 6 look very similar. The only difference is one is f of x and one is x squared as your parent function. Same thing. If we have one that's inside your parentheses, again, if you need to go look at what inside the parentheses is, but that is to the left 5. I should include technically it's translated. Technically, the best answer is if you said translated left 5 units, but I don't care if you put that or not. That's one of those things that if you can know how to do this stuff, then you can learn the vocab later. That can be the next teacher's problem. Number 2, we have a minus 6 outside of your parentheses. Again, just because it's not a parent function, you use it the same way. And if you want to use your table, just look at any of them. What do any of these do if it's outside your parentheses? From outside your parentheses, it's up or down. So this one's 6. And again, doesn't matter if it's a parent function or if it's f of x. It's all the same. Number 3, same thing. We have a negative in front, so that's reflected. Across your x-axis. Same thing down here. This will be reflected across your x-axis. And number 4, across the y-axis. Which is means it's a factor 4. That's the best way to put it is to say vertical stretch by a factor of 4. But as long as you say vertical stretch by 4, I can live with that. Any questions over those first? Those are all one step. You only have one of these. Today we'll do ones where there's multiple. You have to do 2 or 3, 3 or 4 in one problem. Go ahead, do the rest of them on your own, number 11 through 18. All right. Hopefully, and like I said earlier today, or maybe I didn't say to this class, but if you're not good at math, this should be one of the assignments that I'm not saying it should be easy for you, but this is something you can study. This is something that once it clicks, and once you do enough of these, once you get enough practice, you go through really quickly. And I can't even tell you to show your work because there's really no work you can show. Now, I do apologize. Halfway, number 17 shouldn't have been on this part because that is 2 steps. That should be on the next part. But this is what I was talking about earlier, where a lot of people see this and they think, well, it's a vertical compression because -3 is smaller than 1. That's what you're thinking. You're not quite there. A vertical stretch, the only difference is since it's negative, it will be a vertical stretch, but it's after it's reflected downward. So that negative, remember, that minus sign has nothing to do with the vertical stretch or compression. So whether that's a minus sign or not, you still stretch it by a factor of 3. That minus sign just means you reflect, either before or after. This one doesn't actually matter what order. We'll talk about that in a second. Any questions on those? I will say the double-edged sword, these go fairly quickly once you catch on to it. But also, since they go quickly, make sure you're not going too fast and making mistakes, because I already have done that with one of my answer keys today. So the other part of this is when you have multiple. So very rarely on a test or a quiz will I give you ones that just have one set. So all of number 17 just have one thing. You go up 4. Or the next one you did a stretch. Or the next one you reflected. We're going to have multiple ones. Now, anywhere between 2 and I think 5 is the most I can put on there. So you might just have 2, you might have 3, you might have 4. It all just depends. The order does matter. Now, it's hard for me to figure out how I want to say this because the order does matter sometimes. Since it matters sometimes, I'm always going to do it in the same order every single time, and I'm going to show you guys how to do that. However, I will not count you off if you don't put it in order yet. What I mean by that is that later on, and I haven't decided, I mean, I thought, after I said this, I thought maybe next year I should. We'll have to see. But for this year, I don't care for these problems what order you write them down in. However, later when we do the graph, the order does matter. If you move it to the left before you reflect it across your y-axis, that's going to be a different answer than if you reflect it first and then move it. So that's why I'm going to go over this, and that's why you should pay attention to make sure you know what order it goes in. But it's not necessarily for this stuff. It's more for what we're going to do later when we do graphing. So there's 2 ways to know what order to go in. You can either look at it as the order of operations. So you start with the stuff inside parentheses. Everything outside your parentheses line. -7 is the adding and subtracting. The other way you could look at it is you work from the inside your parentheses, and work your way out. Now, I put this, and since you guys are my favorite class, I'll do this for you guys. I did not do this for the other classes. It's set a pretty low bar, so. So if you have the equation like we had earlier, or not the equation, but the format, I have C, and then I did x minus h squared plus k. Down, I don't know if this is the best place for it, but the first thing you're going to do is everything inside parentheses. So I'm just going to put a number 1. And then the second thing you do is everything outside your parentheses in front. That's a 2. And then the third thing you do is outside here. That is your 3. So first, second, third. You said there could be 5 different things you do with this. Part number 2, step 2, if it's a negative, you might also have to do a reflection and a vertical stretch. Those are two different transformations. Now the good news is it doesn't matter the order for those. So again, the hard part is sometimes the order matters, sometimes it doesn't. We're just going to assume it always matters, especially for today, and I'm going to show you how to do this every single time. And later, it'll really come into play here. So first thing, parentheses, so that is to the left 3. There is no step 2. There is nothing in front, so we go to step 3, where you're going down. Problem that it doesn't actually matter which order you go in. And I don't remember if I did this for your class, but if you can think of a single point, if I go to the left 3, at this point, if I go to the left 3 and down 7, that's the same answer as if I go down 7 to the left 3. You're going to end up in the same spot. So this one, the order actually didn't matter. But again, it's good to get this hack. So that's what I'm trying for. This next one, I start with the inside. That is to the left 2. And then that negative means it's reflected. Reflected across the axis. The inside, so I skip to step here. So that is reflected across the axis. Up 6. Then the last one, there's inside 5. The outside here is reflected across x-axis. Plus 10, that's the last step, and then it's up 10. So that only has 3 different things we do. 10 minutes left. Go ahead, and when you're done, please take out your computer or your phone and make sure you're doing that homework check. This is one of those. Make sure you do it. Make sure you're being careful. Before I tell you, before I forget, the homework check is a little bit different. It's not multiple choice. It's multiple where you can check different boxes. So you might have one where you just check one box and that's the answer that's possible. You can also check 2 boxes or 3 boxes or 4 boxes, so on and so forth. That made it a lot easier and a lot less time consuming to list out these transformations.